everyone. So in this video, we're going to go over the problems that are in the Unit 1 test review. And remember that these problems are very similar to the questions that you may see on your Unit 1 test. So in this problem, it says, given the following table of values for a function f of x, what point will be found on the graph of the inverse? So remember, what we're doing when we're finding the inverse is we're taking a point x, y, and we're reversing the order of the coordinates so we get y, x. So all of these points I'm going to take in reverse basically and see which one matches my table. So if I reverse this one, I have 5, -4. If I reverse here, I have 7, 3. Reversing this one is going to give me -1, 6. And reversing here is going to give me 2, 1. So notice that this one is the only one that matches a point that's actually included on my table. So that's going to be the correct answer. All right. So now it says, given f of x equals the square root of x and g of x equals 3x, use the composition of functions to determine if f of x and g of x are inverses. So first, remember the composition to tell us whether something is an inverse means that f of g of x equals x and g of f of x equals x. So we need to check both parts to make sure that these are inverses or not. So if we do f of g of x, that's going to be f of 3x. And so when we plug that into f of x, we get the square root of 3x, and that's already not equal to x. Okay, but just to make sure, let's go over here and try this one. We have g of f of x, so that's g of the square root of x. So when we plug that into 3x, we get 3 square root of x. Okay, so you can see that both of these are not equal to x, so they are not inverses. So now let's try this problem. It says, what is the inverse of f of x equals x minus 5 squared for x is greater than or equal to 5? So remember, when you find an inverse, the first thing we do is replace f of x with y. So we have y equals x minus 5 squared. Now we're going to switch x and y. So we have x equals y minus 5 squared. Now what we need to do is work on getting y by itself. Well, y is kind of inside this square, right? So we need to first get rid of the square by taking the square root of both sides. And when we do that, we get the square root of x is equal to y minus 5, okay? And so now to solve for y, I can just go ahead and add 5 to both sides. And when I do that, that is going to give me the square root of x plus 5 equals y. Okay, so that's now my inverse function. F inverse of x equals the square root of x plus 5. Okay, so there you go, you have the inverse. All right, so now it says, what is the inverse of f of x equals 3x plus 15? So we're going to use the exact same steps that we did in the previous problem. So we have y equals 3x plus 15. I'm going to now switch x and y, so I have x equals 3y plus 15. And now I'm going to go ahead and work on solving this equation for y. So I'm going to subtract 15 from both sides. And after I do that, I have x minus 15 equals 3y. And now I just need to divide everything by 3 in order to get y by itself. So when I do that, remember the x has a 1 in front of it. So this is going to become 1/3 x minus 15 divided by 3 is 5, and that is equal to y. So that's going to be the inverse. F inverse of x is equal to 1/3 x minus 5. So in this problem, it says, describe the domain and range of the function pictured in the graph in interval notation. So remember, domain is x values and range is y values. So let's figure out what's going on here. So the lowest x value that I have is -5, right? So it's going to start there. So we can say that the domain is going to go from -5, and it says interval notation. So that means I need to think square bracket or open parentheses. Notice that there's no open circle here, so I'm going to go ahead and do my square bracket. And then from that point, the x values go to the right, right? Remember, this direction is positive infinity. So I'm going to say -5 to positive infinity and put my open parentheses there. Now let's think about the range. The lowest y value included in my function is right here on the x-axis. Remember, on the x-axis, y is equal to 0. So my lowest value in the range is going to be 0, and I have no open circle, so I'm going to include that 0. Then above that, it just keeps going up, right? And remember that up is positive infinity, so it goes from 0 to positive infinity, and then I put another open parentheses. Okay, so that's the domain and range. All right, now let's try this graph. So we're going to use now set notation. So remember, set notation is where we kind of write our math sentence using symbols, right? So domain is going to be all of my x values. Range is going to be all of my y values. So let's look at the domain. Well, it doesn't have a left boundary, right? Because it's starting off at negative infinity. It doesn't have a right boundary because it's going to positive infinity. Okay, so we're going to say the domain is actually all real numbers. Remember how we write that in set notation is we say all x such that x is going to be any real number, right? X is an element of the real numbers. Now let's think about the range. The lowest y value is 1, okay? And then it includes y values that are above that, okay? So we could say that the range is all y such that y is greater than or equal to 1. Okay, so that's the domain and range. All right, now let's try this problem. So once again, another domain and range problem. Remember, domain is x and range is y. So let's think about this. We start off at the leftmost point and we go to the rightmost point when we're talking about the domain. Okay, so the domain leftmost point is going to be -3. We have a filled in circle there, so we're going to use a less than or equal to, and remember domain is x. Then it goes to +4, okay? We have a filled in circle at +4, and so we're going to say less than or equal to 4. Now let's think about the range. So range is going to go low to high. So the lowest y value is here at -2. That is included because of that filled in circle, so we're saying -2 is less than or equal to, and then range is talking about y. And then the highest value is here at 2, right? So less than or equal to 2. So that's the domain and range in inequalities. So now this question asks, how would you restrict the domain of f of x equals x plus 3 squared to ensure that the inverse is a function? Remember, the way we do this is we look at whatever's being squared. Okay, so in this case, that's x plus 3. We set it greater than or equal to 0, and then we solve for x. So to solve this inequality for x, I'm just going to subtract 3 from both sides. And when I do that, I get x is greater than or equal to -3. Okay, so that's how you would restrict the domain to ensure that the inverse is a function. So that's all the questions in our review.